It's now 7:42.
The Radio Wemo Breakfast.
We're staring into the night sky now with Dylan Storey. Dylan Storey's astronomy. Thanks very much to the Stardom Observatory in Auckland City. Hello to you, Dylan.
Hello, Wemo.
And
hello, everybody.
Yeah, hello. And first up, we're talking about how celestial bodies affect what's going on here on Earth. Of course, the closest celestial body being the Moon. And last weekend we saw some of its effects, and no doubt you're going to explain this a whole lot better than what I can. But the king tide that affected Auckland last weekend with the big storm was totally evident around some of the beaches around Auckland with the sea encroaching on people's houses. Can you explain this spring tides, king tides, and whatnot? What are they? How do they form? And what part does the moon play, Dylan?
Yeah, well, okay. Well, the moon plays the major role in tides. There are other factors, though, which contribute, so that the phenomenon on the weekend with the tides being so high that they were overlapping the roads and stuff, that was a king tide, which is the highest tide you get, combined with other atmospheric effects like the extreme low pressure system of the storm and the direction of the winds and that. So it's a collection of things, but certainly the moon and the regular tides are the biggest contributing factor to that. So I just thought I'd sort of quickly run over what causes tides. So the moon is going around the Earth every 29 days, and it's pulling on the Earth with its gravity, and that affects the water. That sort of pulls a bulge of water up with it, which, in a very rudimentary sense, gives us the high tide. And then at the two sides of the world, you get a low tide, and then behind the world, you get another high tide.
Yeah.
But it doesn't work out nearly as simple as that, because if you look at a world map and there's continents everywhere and gaps and places for the water to flow, and there's the turning of the Earth to take into account as well. So what happens is you get this bulge of water pulled around, but there are so many local currents and it's twisting and falling in different ways that the tides aren't regular, and you can calibrate it to the moon in each location. So you could work out for your location, which way the moon's pulling and what tide's that going to do. But
yeah.
For example, the tides on the west coast and east coast of New Zealand are at completely different times. So it's a really intricate system, but it's basically the moon pulling on the body of water on the Earth, which is causing our tides. Now, as well as the moon pulling, we've also got the sun pulling, and that's got a certain percentage. I think it's something like 10% of the gravity of the moon is. So the water's also being pulled towards the sun.
Huh. So
when the moon and the sun line up, then you're going to get more gravity. You're going to get those two gravities combined,
right?
And so it's going to pull slightly harder, and that will happen, of course, twice a month. That'll happen on new moon, and then you get a sort of an opposite but adding up effect, such as the way gravity works, which happens on a full moon as well. So that means a new moon and full moon you get slightly more pull, which means you get slightly higher tides.
What kind of moon did we have last weekend? Was that full or new?
I think it was pretty close to full.
Yeah. Okay.
So so we got that doubling up effect of the sun's gravity and the moon's gravity, and they're called spring tides, and they happen twice a month. So twice a month you get slightly higher tides, but then twice a year you get what we call king tides, which are caused by the fact that the sun, as the Earth goes around the sun, it's not always equal distance. Sometimes it's slightly closer, in the effect that we call perihelion and aphelion, which aphelion is when it's furthest away, perihelion when it's closest. So if you get perihelion combined with a full moon or a new moon, we get a king tide. So they're generally regarded as the highest tides of the year. But you can get some years you could get atmospheric conditions which sort of cancel that out to some effect.
Yeah.
But this year we had atmospheric conditions which reinforced it.
We kind of amplified it. So the low pressure also had the effect of drawing the water up. Is that right?
Something like that. Yeah. I don't claim to fully understand it myself, but something like the lesser weight of air pushing down on the water helps to bring let it rise higher. But also with a low pressure system, system, of course, you get high winds,
Yeah.
and they're a big factor in sort of pushing great big bodies of water up or around.
Interesting. So that's how we get king tides. Well, on to something completely different. There's a bunch of astronauts who have been practicing, I didn't even know about this, but practicing for the journey to Mars.
Yeah, well, actually getting to Mars is just a little bit beyond our technology at the moment. People estimate that, perhaps within the next 30 years we'll actually get people to Mars. So an important part of the technological progress we need to get there is to get people in the condition and to do research into what the effects are on people as we go to Mars. So the Russians have effectively simulated a Mars mission by locking a group of people in a little capsule, a little space for the amount of time. I think it was about 7 months or something they were in there. So it's basically simulating a Mars mission and studying the effects on the human psyche and the sort of social implications of what happens in there. So they've just, on their journey now, they've just arrived at Mars. So they've arrived in Mars orbit. They haven't got out of their spacecraft yet. In the next few weeks, they have to do a simulated landing. And in mid-February, they're actually going to step out onto an adjacent sandpit, which is representing the Martian surface.
Yeah, and then what? Conduct some experiments.
Yeah, they'll do some experiments and it'll be all simulated with the breathing apparatus and everything, and then they'll spend a bit of time there and then get back in their spaceship in inverted commas and head back to Earth.
But they've just
apparently
so they've been in this thing for 7 months. For, the simulation to Mars. They're going to get out there and stretch their legs for a bit, and then they're going to hop back in for another 7 months for the journey back to Earth, where there's nothing to look forward to because there's no except rather getting out of this capsule. They're journeying back to the place where they already are anyway. How frustrating would that be to be inside this cylinder with these people that you hate now because you've been hanging out with them in this enclosed space, with all their bodily functions. I would not sign up for this.
Assuming they'd put together some sort of appropriate welcoming party and media coverage, some sort of hero's welcome. But yeah, it would be frustrating, and I guess from a psychological point of view, they would have to take that into account, the sort of the effect of the futility.
Yeah, I don't know. See, I mean, I can imagine you could measure the sort of effects on the human body of being in this enclosed space for this amount of time, but I don't know. I think the psychological thing would be quite different, and the excitement of actually going to Mars, because they're hardly going to be excited because they know they're just going to go out to the sandpit. And then I would imagine there would be this excitement of actually making it back to Earth as well if you had gone to Mars, and there would be a lot of fear involved. But in this case, I'd imagine there wouldn't be any fear, there'd be no excitement, just boredom. So I imagine there would. Apparently, sort of fatigue and a bit of depression is setting in, as predicted. Yeah. As you would.
But yeah, it'd be nowhere near the actual thrill of being on that mission, would it?
No. But certainly it'd be interesting to find out how it all goes for them in another, I suppose, just over 240 days or something. Dylan, what can we expect to see at the Stardome Observatory this week?
The night sky show has been, going very strong this week. Because of the clear skies, so we've been going out and using telescopes and having some great results through that. There's a show called Black Holes on at 7 o'clock, and Friday and Saturday nights there is a Pink Floyd show at 9 p.m.
Yeah,
which is this month. It's the album The Wall, with visuals up on the planetarium.
Cool.
So that's been going quite well, and Jupiter's still looking fantastic in the night sky over there in the west after sunset, and we've got Orion and all the interesting stuff that goes with it high in the sky to the east.
Great.
So if anyone's coming along to the Stardome this weekend, it's a perfect time to check